This video we discuss the rock handling and apply the first phase of rock handling, which is loose for drill, and apply to problem 1. So rock handling is a process that includes 4 phases. It's loose, load, hold, and compact. Load and hold we learn in lesson 4, and compact we learn the last lesson, lesson 5. Now talk about the loose, and before we go into detail, let's discuss what are the application process can be used for these 4 phases. If we want to lose a rock, there are 2 ways. We have drill or blast that apply for the hard rock with the on the Mohs scale it's more than 5. If it's the rock that have the Mohs scale less than 5, then we can rip in. And then for load, we can use salvo or wheel loader. Those production of this equipment already discussed in lesson 4. And then hauling also discussed in lesson 4. We can use truck for long distance, wagon in a shorter distance. And then compact, of course, there are multiple equipment to select. But for the rock, to compact it, you can do the steel wheel roller with the vibratory or 10-pin foot compactor, or with the grid compactor. So those are things we discussed in previous lesson. Now we focus on the first phases for this lesson, which is drill and blast. And let me start with the drilling, and what are the pattern we use, and how much the rock we can produce with the drilling. So let's see drilling pattern. Drilling pattern and rock U. So it depends on what your expectation in terms of the size of the rock particle after you drill. The way you set up are not the same. If we want a smaller rock particle, then we will for the pattern we will use small holes when we drill, and of course we closely space between the drill. Closely space. So small holes closely spaced will yield small rock particle. If we want a bigger rock particle, then it will be make a big hole, and widely largely space between the holes, then we use a bigger rock particle. So it depends on the what size of the rock you are going to use. For example, if we use for aggregate in concrete or asphalt, then it's smaller rock particle. Then we use small holes and closely spaced between the holes. And they're basically 2 drilling pattern. Drilling pattern. It is the rectangular and stagger. Rectangular and stagger. So how that different between these 2? If we have the hole and it in rectangle, so I make a hole there, then it second hole, Then we want to drill a hole, then the dot here, that we have one hole, drill another hole, and as you can see it in an array and keep continue. Hold there. Then the effective impact areas in blue circle there, and that is, we call it rectangle pattern. And the distance between the hole, so that is space, and we call S, and as the rectangle or even square, the S in this case the same. Now stagger, we drill the hole, the first lies, it will be the same. So the effective area when we blast, it will be like that. But for the net drill, we don't go in the same line. We make the whole stack. Make this whole stack there. So that pattern we call stagger, and then keep continue, drill a hole, and we have that, drill a hole, we have that, and then keep for another layer. The blue is the effective area impacted if we blast. And from that one, as you can see, the S for the same, the space the same, but because stagger, the S, the distance here between the row is not S anymore, but with the geometry it will be 0.866S. 0.866S. So from that we can determine the rock views for each pattern. Example, if we want to determine the volume for each hole in cubic yard for rectangles, then we can determine with the equation. So the volume or rock view per hole, and in cubic yard it will be equal to S square time the effective depth of the hole divided by 27. That basically transfers from feet, cubic feet to cubic yard, and this apply for rectangle pattern. Pattern. So what is H, what is S, and what is the how to determine the H. So as you can see, for H in this case it effective hole depth, especially hole depth. And it measures in feet because we already divide by 27, which is the unit conversion. If the problem don't give anything, so then it's about 90%. It's about 90% of original depth, the depth that we really drill, original. But if the problem gives us, then we use that number given. And then we have the S. That is the pattern spacing. The space between the hole when we drill. And that also measure in feet. So as you can see, feet, S square, H, it will be cubic feet divided by 27, we get cubic yard. So that we know how much volume of rock we can yield with that excavation. And from that we can apply easily to problem 2. A trioblasting indicates the rectangle pattern, so that already given rectangle pattern. So the left one, drilling using 3-inch hole space, so that it give us S. This is S. On the 9 feet centers and 20 feet depth that we have here. And we produce satisfactory rock break with a particular explosive loading. About blasting explosive, we will talk in the next video. The effective hole depth resulting from the blasting is 18 feet. So that is H in that equation. And this guy given, so you don't worry about 90% of original depth. Original depth here is 20 feet, as you can see. The question is determine the rock volume produced per foot of drilling. Volume per foot of drilling. So with that, we can use that equation to determine the first is the volume, that is the question asked. But first, the equation here is volume per hole, and the question asked is determine the volume, determine the rock volume produced per foot of drilling. So they are different units. So unit is very important. First, we need to use the equation it given for us. So volume per hole, how much I can produce the rock. And it equal to S squared times H divided by 27. S, in this case, the 9 feet center, so that is S in here. Not 9 inches hole, it means the diameter. So this is the diameter, not S. This is diameter of the hole. So basically the dot, the black dot in the space in there, that is the diameter. And this is the S, and this is H, effective depth. So we have that. So plug in. There we have 9 feet square time 18 feet divided by 27, and we will get 54 cubic yard per hole. Cubic yard per hole. So that is volume per hole. The question is, what is the volume per foot of drilling? So we drill basically here 20 feet depth. So how much I can produce per feet that I drilled out? So that is basically the unit volume, right? So here we have volume per unit depth, and it equal to 54 cubic yard per hole, and divide by, for the actual depth that we want to drill 20 feet, but the effective is different, 18, right? So that one is, we have to know, okay, I have to spend to drill 20 feet. So that is divided by 20, not 18. 20 feet per hole. So from that we can cancel our hole. So we have 50 divided by 54 divided by 20. So you get 2.7. The unit is cubic yard per linear foot of hole. Linear foot of hole. So with that we can done for the problem here.